That's all it is. Okay? This last one, what I really want is I want the area greater than 1.4. So I want this area right here. Well, I can either take 1 minus 0.9192. Okay, that would be 1 minus the area I found to the left. Or equivalently, what I can do, because I know this is symmetric, the area to the right of 1.4 is exactly the same as the area to the left of minus 1.4, which is 0.0808. Okay. So either way of looking at it works fine.
What if you said like P is, like for the last one, if you said like P is greater than or equal to 0.9192? That's like the reciprocal of 0.08.
Yeah, not really, because what you got is that this probability is the probability of seeing a Z that is 1.4 or higher. So that's the probability of seeing this over here. So that probability is exactly 1 minus what's over here. So it's going to be exactly 0.0808. So think of it that way. I think I see what you're thinking. Try to turn it around so you're looking at this way.
Yeah, it's like the inverse.
Yep. Okay. How about, what was the next one? 836? 936. Yeah, 936.
So if you were to give us a problem like that in an exam, we would have to have a booklet on that.
Yes.
Right?
That, or I would give you tables equivalent to these. Yeah, I don't expect you to memorize the tables. Okay, 936. What was the first problem, part of that one? We're given the probability is 0.2, p equal to 0.2, that a person who purchases a lottery ticket wins money. You've got different random samples of size 64 purchased tickets. P hat is a sample proportion of winning tickets in a sample of 64. So you're taking random samples of 64 tickets. You're finding that in those samples of 64 tickets, you're getting some proportion of winning tickets out of it. Now, it says to give the numerical value of the mean of the sampling distribution of p hat. What is that? Sure. Now, normally we don't know this value, right? But in this case, they told us what the value would be. So, we're saying that it's 0.2. Part B, calculate the standard deviation of the sampling distribution. So what's the standard deviation of the sampling distribution? Right there. Right?
1 minus 0.2 over 60.
Actually going to be equal to 0.2 times 1 minus 0.2 over 64. Okay. And C, using the empirical rule, find values that fill in the blanks. Essentially, they want a 68% confidence interval. Okay, a 68% interval. So in C, the center is going to be what? Center is going to be 0.2 plus or minus 68% would be how many standard deviations? 1 times that thing there. 0.05. Okay. Part D, they wanted a 95% interval. That's 0.2 plus or minus for a 95% approximate interval. We use a 2 times 0.05. That thing right there. Okay. 1024. We have a randomly selected sample of 400 registered voters. 220 individuals say they plan to vote for candidate Y. Find the sample proportion planning to vote for candidate Y. So what is that?
220 out of 400.
Okay. What's that come out to? 0.55? Part B says you want a standard error of the sample proportion, so what should that be? Right there. So that's 0.55, 1 minus 0.55, divided by 64, the n, square root. Somebody calculate that? Oh, I am, ain't I? Actually, that's 400. Wrong problem, isn't it? Okay, so what's that come out to? Anybody calculate it? Personally, I don't care if you calculate it out. I'm more interested in this than I am in this right here. And in fact, there were cases that I saw on the midterm where I would see people putting the right values in, but the value on the other side of the equal sign, I had no idea where it came from. So I gave them the points anyway. Because if you've got this all here, between here and here is just punching your calculator, and I really don't care that much about how well you get that done, as long as you get this piece done. Part C, 95% confidence interval. What should that be? What's the center? 0.55 plus or minus 2 times 0.025. Okay? You could use 1.96 here if you'd like. And a 98% confidence interval? Nope. That's a 98. We want to use 2.326. Times 0.025. Okay? That's it. We'll see you in the lab on Friday.